Hi guys, welcome to another cool films. Alright guys, so in this cool film we want to draw the curtains to a, a series or I don't want to say a series but a different whole chapter that we want to start looking into, and that's with regards to implementing large scale software systems. We've actually taken our time over the course of the production to look at some essentials that comes to developing softwares, and we want to actually go deeper and try and cover as much as possible in regards to the final, I won't say the capstone, but there's a level that when we get to in the software process we actually can see that okay, we are now okay. So I want us to get to that level, and that level is actually with regards to implementing large scale software systems, and this is mostly the non-functional requirement bit of the software development. For the function requirement process, whereby you have your use cases, you have your scenarios, and you have to write your functions, and even in regards to the kind of architecture, whether you're going to go with MVC and whether you understand even what the client wants, at least that basis is okay. Or with regards to the component architecture, that basis is okay. But in this code field, we want to go deeper by starting to look at those large scale software systems concepts. We've already looked at DevOps. If you haven't seen our last video, not extensively, but at least just having that visual mind cap so that any task that comes, we're able to orient our mind around the task. Then with the basics and foundations, we get the job running. We are not really here to be experts on DevOps, and concerns are also around Spring security. So if I'm to address the remaining half of our year, we are mostly going to be looking at implementing large scale software systems. We're looking at Spring security, mostly cyber security software solutions or security as a whole. And the last one will be with some still advanced Java concept or just SOE. So we are moving to a different level. We are no longer going to be looking at what we've looked at before. So we just want to tune our minds to know what we're expecting the following cool film. Just to get a clean shot of what we want to do, we'll go to our ID, and just for here, for instance, I'm trying to work on something around reliability and default values. And it's actually default values because most of the time when we start to write code, let me just have a main class here. Just sorry, a main method here. We tend not to appreciate some concepts, so we have an issue, or when we are working, then we realize that we actually need this um we need this concept, or we need this knowledge to be able to do our work. So I'm trying to start my main. It's not comes to public static void main, then string, then an array. Okay, so okay, we're not in the class. That's one reason. Right, so we'll start with the class. All right, so we have our public static void main here, and this is just a normal Java class, just as a controller with some annotations that are just decorating the objects. So we are just we've decorated our objects with some annotations, but that's not going to affect what we want to do. So in the series of code films we want to be that'll be coming out, we want to look at something around reliability. We want to be looking at performance. We want to be looking at security. We want to be looking at scalability, and all these are part of the software process, or it tells you how your system should be able to handle some of these things. And in other words, these are the non-functional requirements. For example, let's say you have a payment app. The payment app I'm using, I didn't build it only for myself. I built it for end users to use, or I built it with a mind of letting the world use it. So if it performs its functions correctly, if the functional requirements have been met correctly, then the non-functional bit of it also must be addressed. Otherwise, people say that my app is not good, or my app doesn't respond, or my app doesn't allow them to do what they want to do. So we get the picture right with the functional requirements. But hey, if the non-functional requirements also are not working or are not considered or are not looked at, which means that we didn't do anything at all. So in this series of code films, we want to start looking in that, and also some basic little nitty-gritties we leave out when we are eager to learn maybe the new programming language. For example, example of what we want to be looking at in the series of code films is something in regards to default values. We all know that when you declare a variable, most of the time we don't even care what the default value is. Once declare a variable, I just go ahead and then I want to use the variable, I'll just say X. And Java being robust as it is, if you have a variable in a method, you have to actually initialize the variable. You have to let it have a value. You can't go ahead. That's the robustness of Java. It's a robust language, so it enforces you to define a value for the object that you want to use. So no object being used in within a certain scope shouldn't be left idle. Every object in the real world has an identity or has a value. So in the same way, you also have to have an identity or a value, and it makes your applications very robust. Because of this emphasis from the compiler and other things. We'll look at that too in another cool film whereby we just scrape out some of the Java is this and that, but we don't really see it in real life or in real terms programming unless we have issues or we are stuck in the loop. Then we decide, oh, that's why they said, and oh, that's why they said. So once we gave it a value, we realize that the compiler no longer complains. It actually wants us to give it a value, then we can run the application. So we avoid unexpected crashes here and there. So it makes your application robust. All right. So that's just one way. That's just for you to know. But there's a default value for X. So if I go ahead and declare another value here, int X here, you realize that the int X here has doesn't complain that I should give it a default value. It's actually part of the class, and this is a static method. So we have an instance variable, but the instance variable, you can't call an instance variable in a static method. You actually have to call it in a different fashion. So if you want to call this value, you have to actually go with a reliable. You have to say this is an instance method. So you can just do this dot x, and that should work. But because it's a static class, as we've explained, it's not going to allow us unless we take out the static, then we are going to say this dot x. But once it's a static method, we have to go ahead and go with the two ways. Either we instantiate a new, so we say new reliable, just for us to understand the default value concept, new reliable controller, then we'll say dot x. So this is just the way that we can go about it. And even with this approach, we have to, let's pass it to x here. Yep. So just to make it assigned. So we'll say new reliable controller, then dot x. So we have been able to access the instance variable here. All right. So the instance variable we've been able to access it here by going by this approach. So the method is static, all right, but you can actually call the instance variable once you instantiate a new object to have that object. Then in memory, you can actually go and pick the value out of it. So it's not going to be affected by the static. But if you decide to call it without through an instance with this approach, it's not going to work because the method is static, which means that it belongs to the class. It doesn't belong to the property. It belongs to the class. So you have to go by class approach, or you have to find a way around, and that's what we've just done. I don't want to go too much into that. So we've just done a new then reliable controller.x. So we have a method. So you can just say reliable, you can just say reliable controller. You see how C is equal to this, then this makes sense. And we say how C dot x, and x can be equal to this. So I think this will make has a more visual appeal. So with this, what we are just trying to say is that we have a new instance variable. We have a new instance that's in a static method, which we don't have an issue with. But if you decide to call static variables that are not supposed to be called inside the static method, it's not going to allow. But this is a new instance variable, just as we've seen it is a new instance variable. Is you're getting it straight from memory. Then we just do rc.x, then we assign it to x. Then we go ahead and use x here. When we go by this approach, we realize that x has a different value as compared to x here. X here is going to be 1, but the x coming from this value has a default value, and the default value is for for variables that are declared within classes. Instance, the default value is 0. That's for int. So if you go ahead and call this, you realize that this has to be 0, and then there's a reason to that. So once we go ahead and run this, all right, so we first realize that here we have 1, and here we have 0. So which tends to tell us that the instance variable we created within a class allows us to allow us to have a default value for it, which is fine because it belongs to the class. You've created a class, you have to define the properties of the class by defining it with maybe your own values. But as you haven't yet done it, there's an instance variable for it, and it's all coming from the heap and the JVM bit of it, which we'll look at to it as we said earlier in another film. But as it stands now, when we created a new object, the new reliable controller, we have RC here. We're able to call the property via the object. So we say RC dot x. Then when we check what is in x, we realize that x has what 0 because there's a default value for it inside, or there's a default value assigned to it, and we are going to use this and assign to build on reliability because we can actually do the term is maybe we can actually do a failover, a fallback. We can do a fallback on that because we know that once we don't give it a value, there's a default value assigned to it, and with that default value, we can define so many processes and operations that can take place with you not being able to give it a value because of a use case that you have. So that's what we want to be looking at in this code film. So we want to start digging deep slightly into that reliability. And in regards to performance too as well, we have a code film here. We have not just a code film, a code that we have here that will help us look into performance and how our application is supposed to respond to performance and something around that. Yeah, some mostly around the keyword, or what I have to actually say is mostly centered around latency and throughput. Throughput. So these two words will be buzzing a lot when we go into performance. Then we have some processes here that we'll be looking at. And lastly, for the security bit of it, we have an unsecured application that we haven't actually started anything yet, but with the understanding that we want to share across, or what we want to understand, if we have an unsecured application and your system is not able to handle security, which means that any end user or anybody on in this world can actually enter into your application and do whatever they want. And a lot of people's information are very sensitive information. There are a lot of information that is not supposed to be shared, especially medical records, personal identification records. So many information are not supposed to be made public um, because of the world we are living in. Yeah, and so we have to be able to sanitize and and ensure that what has to be kept secret has to be kept secret, what has to be made public has to be made public. So we'll start looking at that when we look at unsecured applications and security as a whole, whereby we look at something around authentication, we look something around authorization, we look at something around secure coding, we look at something around OWASP top 10, we look at something around um, roles, users, groups, a lot more, a lot more in this unsecured. application. So at least we have a general overview of what we want to do. All we want to do is we just want to get started. So how do we get started? And that's what we'll be doing in the series of cool films that we'll be bringing out. So this is cool films for you, and this is for the remaining section of the remaining half of the year, what to expect and the journey so far. So I think so far so good. Uh, we've had the opportunity of releasing a number of cool films, and the last bit of it that probably we haven't yet pro- properly covered is testing, unit testing, and why we need to write test and why testing should be really considered even as you develop. Most of the time, testing is not really done from our end when we want to actually do something. We just write the code and we test either with Postman and we get the feedback. But there are a lot of tools out there that helps us to leverage um, on testing whilst we are writing code. So if you're really conversant with it, it's not going to be a struggle. But whereby you haven't even written one test case before, you realize that writing test cases is going to be an issue. And it's not part of you. That's what it simply means. Yet, so we also look at that, and basically we've tried our best to appreciate or look at so many things in this in this series, especially the enterprise infrastructure basics and the developer series. We looked at a lot of stuff. So going forward, we are going to now branch into three worlds, and to close the curtains, we want to bridge into large scale software systems. Example is if you go to Amazon, how is Amazon handling all the load and requests coming from several end users across the globe? Amazon is not just in my country, Amazon is everywhere. And it's not just selling one product, they are selling a variety of products. So, how are they handling all this? And we look at them and realize that it's not as difficult as it presents itself. So, our focus is going to be on this. Our focus is going to be on, let's have a lighter marker here. Our focus is going to be on this, and that. So, three areas: security, large scale, and then more advanced concept, the Java. Yeah, so we'll gradually take our time and start considering all these stuff so that we actually appreciate everything. So to wrap up, this is a new series. We're entering into a new chapter, and we just want to appreciate to understand what we are going to be seeing in the following cool film. So stay tuned, don't go anywhere, and keep the comments and the subscriptions coming so that we actually do more and share more and get more solutions out there. So this is cool films, and thank you so much. Bye.